So in the scores table, let S be the list of sequence numbers of rows which have marks greater than 75 in at least one subject. Now we want to know what the variable count represents at the end of execution of this particular pseudocode. So we first initialize count to 0, and then we go through each row in table 1, and for each row we also iterate through each element C in the list S, and inside the for each we check if this particular row sequence number is equal to C. If that is true, then we check if the mathematics and physics marks are less than 75. In that case, if that evaluates to true, then we increment count. Right, so this is the flow of the code, and clearly count is representing the number of students who satisfy some conditions. So let's see what conditions they are. The first is that the mathematics marks and physics marks both should be less than 75. That comes from this. The other condition is that the marks of this particular student should be greater than 75 in at least one subject. Now this comes from the fact that this element C belongs to list S, right? So, and the list S has all sequence numbers of students, or rather the list S has sequence numbers of those rows which have marks greater than 75 in at least one subject. Okay, so since this is a nested if condition, we put them together, we get for this particular student, the mathematics and physics marks are both less than 75 and chemistry marks are greater than 75, right? Only students who satisfy, or only rows who satisfy this condition, right? These three conditions here, only such rows are going to be counted. Therefore, count represents the number of students who have scored less than 75 in both maths and physics, but more than 75 in chemistry. And that ends the solution to this problem. So the following pseudocode is executed on the words table. Assume that all the rows in this table are sorted in the increasing order of sequence number. Now what does the list L contain at the end of execution? Right, so we have an empty list to begin with, and then we have some lines of code here. So let's just take an example and see how this particular pseudocode works. So let's say that our paragraph is, in this case, just a sentence. It is a good day, right? Let's say this is the only sentence that is present in the words table, right? And each one of these words will have some part of speech, right? With this as an example, let's go and see what's happening. So A is initialized to none. So usually we initialize strings to none. So A is set to none, and now we read the first row X in table 1, and we assign the part of speech of this first word to A. So A now holds the part of speech of the first word in the paragraph, or in our case, the first word in the sentence. Now we move X to table 2, right? And now we begin the while loop. We start with the second word in the paragraph, right? Remember this. We have already seen the first word, right, which happens to be the first row in the table, and we have moved it aside. Now we start from the second word in the paragraph, right? And then we are going to check if the part of speech of this particular word is a noun, right? Only if it is a noun do we go ahead and execute whatever is there inside. If it is not, we just move on and update it to be the part of speech of the current word. Okay, now if the part of speech happens to be a noun, then we check if A is equal to an adjective. In that case, we append the current word to the list L. Alright, so let's go to this example here. So the column step refers to the step of the while loop, right? So to begin with, there are no steps, and then we go through the first step of the while loop, second step, third and fourth, right? X refers to the first row X in table 1 as usual, and this is the part of speech of X, and A refers to this variable A, which is storing the part of speech of some word in the sentence. So before entering the while loop, we have already read the first row in the sentence, or in this table. So that is it, and it's a preposition, and we have updated A to be the part of speech of the first word. So A will hold the value preposition even before we enter this while loop. Now, when we enter this while loop, remember that we are going to read from the second word in the sentence, right? So we are going to start with is. The part of speech is verb. Now, we won't enter this if block at all because the part of speech of the current word is not noun, right? So we'll just skip all these lines and we'll go and update A. A will now become the part of speech of this current word, which is verb, right? So at the end of step 1, A will be verb. So notice that this A refers to the value of A at the beginning of the loop, right? At the beginning of the loop, whatever value A has, that is what is represented here, right? So at the beginning of the first step of the loop, A was a preposition because that was the part of speech of the first word, right? At the beginning of step 2, A is a verb because that was just updated at the end of step 1. The value of A was updated to verb at the end of step 1. So at the beginning of step 2, the value of A is verb, right? Now we have picked up the next word from the sentence, which is A. A is an article and not a noun again. We are going to skip this if. A will be updated to an article. So at the beginning of step 3, A has the value article. Again, the current words part of speech is not a noun, so we go ahead. Now A is updated to be adjective in the fourth step. And finally, we have the part of speech to be noun. Okay, we have part of speech of the current word to be a noun. So we enter the if block here and we check if A is adjective. In this case, yes, right? There is a nested if here, and the second part of the inner if is checking if A is an adjective. It is true, right? So finally, we are going to append the current word to L. Okay. So what is happening is that we are appending nouns to the list L, but not all nouns, right? We are only appending those nouns to the list L which come immediately after an adjective, right? So how do we get this clause here? How do we know that it is immediately after an adjective? That is because the variable A is storing the part of speech of the previous word in the sentence, right? If you notice at the end of the loop, just before the loop ends, we update A to be the part of speech of the current word X, so that in the next step of the iteration, A will store the part of speech of the previous word. For example, at the beginning of step 2, A stores the value verb. What is verb? Verb is nothing but the part of speech of the previous word, right? So what we are checking in this nested if is that is the part of speech of the current word? No. If yes, if that is true, is the part of speech of the previous word adjective? If true, then we are appending the current word to the list L. So it's like adjective followed by a noun. Only such nouns are going to be inserted or appended to the list L. So the correct option is the list L contains the list of nouns that come immediately after an adjective, as we can see here. And that ends the solution to this problem. So in this problem, we have a list called auth list that stores the names of authors in alphabetical order of author names, and we want to extract the list of unique authors from this list. Okay, for example, consider this list here. So auth list has these elements, and as you can see, there are repetitions. And we want to extract only the unique list of authors from this, right? So the first observation that we have to make is that duplicates will occur adjacent to each other. This is because the list is sorted. So if you have two columns, then they are going to occur one after the other, right? So now what we need is unique list should be this set of elements, given that this is auth list. So let's now go back to the code. Let's see what's happening. Unique list is set to an empty list, which is correct. The second line is erroneous, right? So we are trying to append two lists, right? The way it should happen is unique list should be set to unique list, right? So this is the correct syntax. We need to enclose it inside the square brackets. So this line is erroneous and this is the corrected version of that particular line. So we move on. Line 3 looks harmless. It's just storing the first element in auth list to the variable previous. So now previous is now Kalam. So please ignore the font here. I'm not making these bold in the interest of time, right? So currently previous, the variable prev, which represents previous, stores the first element in auth list, which is Kalam. We go through each element in rest of auth list, right? So what will rest of auth list be? Let's see what that will be. So we ignore the first element and everything else we take it up. That is what rest of auth list is going to be, right? So this is rest of auth list and we are checking if the current element x is equal to previous, right? So the first element in rest of auth list is Kalam. We are checking if Kalam is equal to Kalam. In this case, we are appending that element to unique list, right? So if we actually go ahead and execute this, what will happen to unique list? Unique list will end up having two versions of the same element, right? I mean, it will have duplicates, which is not what we want. Okay, so clearly there is an error in line 5 because see, line 6 is not among the options, so this append is anyway going to happen. So the error has to be with line 5. So the correct version of line 5 is if x is not equal to previous, then you append x to unique list, right? So this is the corrected version of line 5. So we go through the rest of auth list. Whenever the current element is not equal to the previous element, only then we append it to unique list, right? So that ends the solution to this question. So in this question, we again have to find the errors. So we need to enter a shop as parameter to visited shop here in this procedure, and visited shop returns the list of names of all those who have visited this particular shop exactly once, right? Additionally, each customer who has visited this shop, we should represent this customer exactly once in the return list, right? So right away we can see that since visited shop is returning s and since s has to be a list, s cannot be initialized to none. So line 2 is an error. It should be a list, therefore s should be initialized with the empty list, right? Now we go through all the cards in pile 1. There doesn't seem to be any error in lines 3 and 4, and here we are checking for shop name whether it is equal to the input parameter shop. If that is true, then we enter this block here, and if this customer is not a member of this list s, then we are appending this shop name to the list s, right? So line 6 seems to be all right. We are checking if the customer is already present in the s, in the list s or not. Only if it is not the case, only if the customer is not present in the list s already, we are doing something to the list s. The problem is with line 7, right? So we should not append the shop name to the list s because we have been asked for the list of names of people, right? So this should ideally be x dot customer name, and that gives us the next error. So line 7 should actually read as follows: s equal to s plus plus x dot customer name, right? Now how did we figure out that the member function is actually finding if the customer name is in the list S. Now this is something that is should be quite familiar to you because we have already seen the member function in the tutorials, right? So all that remains for us to check is if the procedure member has been defined correctly. So member accepts a list L and name as inputs. Now it begins with present equal to true. We'll see if this is an error or not later. And it goes through each element X in the list L. If the element X is the same as the name that we have input as parameter, then we say that this element is present in the list L and we return true. Rather, we say update the value of present to true and then we exit the loop, right? So if the name is present in the list L, we update the value of present to true and then we exit the loop, and outside we return true. Now if this name is not present in L at all, then what will happen? Present will never be updated, and by default we will return whatever is there in the value of present. But observe that in line 15 present is set to true, so it will return true always whether the name is present in the list L or not. Now clearly this is not the behavior that we want. If the element name is not, rather if name is not present in the list L, we would like to return false. Okay, so by default line 15 should be false, so that if this condition is never met, present will never be set to true and then it will return false. That is, name will not be a member of list L. Right, so that there are three errors, one in line 2, one in line 7 and one in line 15, and that ends the solution to this problem. So in this problem we are given a list marks that has physics marks sorted in ascending order, and we need to find the element that occurs the most number of times. If there are multiple elements which occur the same number of times, the most number of times, then we return the smallest among them. So let's take this example. Marks is this list sorted in ascending order. Okay, and let's go through the code line by line. So previous is a variable that's initialized to first of marks. So here in step 0, that is before the for each, we have previous equal to 50. M frequent is updated to 50 or initialized to 50 again. Count is set to 1. Max is also set to 1. Right. So this is step 0 or before we enter the for each. This is the state of the variables that we have. Okay, now we enter the for each. So we go through rest of marks. So rest of marks is nothing but this. We pick up the first element. So since we are done with step 0, I'll just make step 1 bold. So previous is 50. X is 50 now. Since X is doubly equal to previous, we have encountered one more element that is equal to the previous element. So we increment count. Right, and since we have found something greater than maximum, we update maximum and also the most frequent element. That finishes step 2. In step 3, previous remains 50, but we are picking up the next element in rest of marks, which is 60. Now 60 is not equal to 50, so the else part gets executed and count becomes 1. Right, so we are no longer having the previous element at the current position. We are having a new element which is not equal to the previous element, so we move to the else part and set count to 1 so that we can start counting this new element. Right, so at the end of step 2, previous becomes 60. So in the next steps beginning, we'll have previous as 60 and we pick up the next 60 from rest of marks. Right, so since they are equal, I'm going to increment count becomes 2. Right, now notice that count is still not greater than max, so I don't update max or M frequent, and I finish this step and I move to the next step. Here I take up the next 60 from rest of marks, I increment count now and M frequent becomes 60. And finally we take up the last step of the iteration. We pick up 70 from rest of marks, Since previous is not equal to the current value, count is set to 1, max remains the same, right? Now what happens if there are an equal number of, what happens if there are multiple elements that occur 3 times, right? In this example, let's say there are the 70 occurs 3 times. So the procedure should return 60 and not 70. Let's see if it does that, right? So now the previous is nothing but 70, and I'm picking the next 70. Count is going to be incremented to 2, max is till 3, and m frequent is still 60. Now previous still remains 70, and I'm going to pick up the last 70 from this list, right? Count becomes 3, and here's the interesting part. Okay, max is not going to get updated even though count is equal to max, right? Notice that max will be updated only if count is greater than max, right? So we are going to leave max alone. We are going to leave m frequent alone. Even though 70 also occurs 3 times, the procedure will finally return 60, right? Now if we had instead wanted the highest or the largest element to be returned, when there are multiple elements which occur the maximum number of times, we should have changed this to count greater than or equal to max. In that case, we would have obtained the last element or the largest element that occurs the most number of times. Since we want the smallest element, we have it as count greater than max, and that ends the solution to this problem. So in this problem, we are going to execute this pseudocode on the words table, right? So start is a variable that is initialized to true, and we have a variable called outlist that is initialized to an empty list. All right, so we go through each row in this table. So since we are taking up the first word in the paragraph or the first row in the table, and since start now is true, we enter, and we initialized in list to be an empty list, and right away we set start to false. Now we come out and we append the word and the part of speech. Rather, we append the list containing another list, and this, so this is a bit complicated, so let's break this down. In list, we are appending something to in list, right? And that is itself another list, and that list has 2 elements. The first element is the word, the second element is the part of speech of the corresponding word, right? So we are appending a list to in list, right? So we are appending this list to in list, and that list is nothing but the current word, that is the first element, and the current word's part of speech is the second element, right? So now we go on. Since this word, current word being the first word, and in this case it doesn't end with a full stop, so we skip this. So if you notice, at the next step of the iteration, start is actually false, right? So start is updated only if the word ends with a full stop, right? And it, since it's, so start is updated in only 2 places, here and here, right? So when we started off, we updated start to false here, and since it was not the last word of the sentence, we didn't update this start here, so start remains false. So this is not going to get executed, or rather the statements are not going to get executed, and then we go ahead and we append the next word and its part of speech to in list. Now this will keep going on until we hit a word that ends with a full stop, in which case we add this entire in list to out list, right? And we set start to true. Okay, so when we go to the next step of the iteration, we are going to start with a new sentence, and notice that at that stage start is true. All right, So whenever we come to the last word of a sentence, start is updated to true, and whenever we begin with the first word of a sentence, start is updated to false, right? And for every word and its part of speech gets appended to an in list. Okay, and when the sentence end, in list is added to out list, or in list is appended to out list. So out list is nothing but a list of sentences. Each element in out list corresponds to one sentence from the paragraph, right? And the other important part that we need to notice is whenever we begin a sentence, right? Whenever we begin a sentence, in list is set to the empty list. Now, if this initialization were not done, then we will keep adding new sentences to the old sentence, which is not what is happening here. So every time we begin with a new sentence, in list is initialized to the empty list, right? And to this list, we keep adding the word and its part of speech. And whenever a sentence ends, the in list or the corresponding sentence is added or appended to out list, right? And we set start to true so that we can work with the next sentence. All right. So the solution to this question is that out list is nothing but a list of lists, right? And each element in out list corresponds to one sentence from the paragraph. As for the next part, we see that the variable start is set to true at the last word of every sentence, right? Notice that at the last word of every sentence, start is set to true, and at the first word of every sentence, start is set to false. That's the other option. It's set to false at the first word of every sentence, right? And that ends the solution to this problem. So we are going through each element X in outlist. Remember that each element X in outlist corresponds to a sentence, right? And there are as many elements in X as there are words in that particular sentence. So length of X is nothing but the number of words in that corresponding sentence. So somewhere is counting the total number of words in the paragraph, right? So that's what somewhere is doing. Now X, as we know, corresponds to a sentence from the paragraph, and X is itself a list, right? It's a list, and for each element Y in this list X, we are checking if the last of Y is known. Now remember, each element in this list X is itself a list. It has two elements. The first element is the word, and the second element is the part of speech of that particular word, right? X corresponds to a sentence, and each element Y in that sentence is again represented as a list. The first element of that list Y is the word, and the second element of the list Y is the part of speech. So whenever the part of speech of a particular word in the sentence is a noun, we are incrementing count. So count is nothing but the total number of nouns in the paragraph. Okay, finally we have something called I here. Now I is incremented for each element X in outlist. So I stands for the total number of elements in outlist. This is also equal to the length of outlist, which is again equal to the total number of sentences in the paragraph, right? So there are three different ways of saying it. Since outlist is a list of sentences, length of outlist is the same as the number of elements in outlist is the same as the number of sentences in the paragraph. And that ends the solution to this problem. This question we have stations. It's a list of stations visited by a train from the trains data set, right? So the each element in stations is of this form. It's itself a list. So the first element will be the name of the station, and the second element will be the distance of this particular station from the first station in this original list stations, right? So we want to find a pair of stations that are closest to each other on this route, right? And in the first part, if there are multiple pairs having the same minimum distance, we wish to find the pair which is closest to the first station, right? So this is more or less a straightforward code. So we start with pair which is initialized to none and none, and minimum is set to some high value called, say, let's say 10,000. So previous is the first element in stations. Now remember that each element in stations is a list. So previous will have two elements. It's a list of two elements. Now we go through each x in the rest of stations, and we find the difference or the distance between the last station and the current station, right? Or the distance between the previous station and the current station, and that is given by last of x minus last of previous. Why is it last? That's because the last element in the list is the distance, right? So difference is given by last of x minus last of previous, and that directly takes us to the correct option here. So if we have found a difference that is less than the current value of minimum, then we update minimum, right? And we also update the pair of stations. Now why is the pair of stations first of previous comma first of x? That's because the first element corresponds to name, right? And we want the names of the stations, right? So that is why we have pair equal to first of previous comma first of x, right? And to find the pair closest to the first station in the list stations, what we need to do is we need to keep this as diff less than minimum, right? To find a pair of stations that is closest to the destination, we need to have this as less than or equal to. This is because if we find a new pair whose difference is equal to minimum, then it will keep getting updated. As long as we find a new pair that has the same minimum distance, minimum will be updated, and it will give us a pair which is closest to the destination station, or rather the last station on the list stations. And that ends the solution to this problem. So in this question, we have stations, STNS, that contains information about the sequence of stations visited by a train. Okay, and each element is itself a list. The first element of stations will be the starting station, and the last element of stations will be the ending station. And we need to find the average waiting time across all intermediate stations where this particular train stops. Now the catch here is that there is no waiting time for the starting station and the ending station, because in the starting station the train is going to just depart, right? There is no concept of arrival, it's going to depart. And in the ending station the train is just going to arrive, there is no concept of departure, right? So for the first and last station in the list, we have no concept of waiting time. So this waiting time only holds for the second, and from the second to the last but one, or the penultimate station in the list of stations, right? So for example, if this list stations has n elements, right, we are only interested in the second to the n minus 1 elements, right? We have to ignore the first and last elements. And if you notice the pseudocode, that is exactly what is happening. Rest of stations ignores the first element in stations. Init of rest of stations ignores the last element in stations, right? Rather, the last element in rest of stations, but rest of stations has already ignored the first element. So init of rest of stations put together will ignore the first and last element in stations. So it will contain all elements starting from position 2 until position n minus 1. And for each of these elements x, what we are doing is we are computing the waiting time, all right? And we are storing that waiting time in total, or rather we are accumulating the waiting time of that particular train and station corresponding to x in total, right? So how does this work? X itself, if you remember, is a list. First of x is the arrival time, last of x is the departure time, and wait time is a procedure that accepts the arrival and departure time and returns the waiting time. So we are accumulating the waiting time at a particular station in the variable total. So there is no error in line 3. Count is nothing but a variable to keep track of the number of intermediate stations, and that is also happening fine. And the for each, as we just saw, has to go from the second to the last but one element in stations, which is exactly what's happening. And finally, when we come out, if count is not equal to 0, then we compute the average as total by count. Therefore, if you notice, there is no error at all in this particular pseudocode. Now, why do we do this count not equal to 0 business? That is because there might be a case where a train starts at one station and stops at another station without having any intermediate stops at all. In that case, init of rest of stations will be an empty list. So we won't execute these lines at all. So if we just do average equal to total by count, we will end up dividing by 0, right? So we need a check here which says whenever count is not equal to 0, only then do this. Otherwise, by default, the average will be 0 because the train does not stop at any intermediate station. So there is no waiting time. So the waiting time is 0 in that case. So I hope this is clear. That ends the solution to this problem. So in this question, trains is a list that contains information about trains associated with a station called STN. We'll call that STN. So each element in trains is itself a list, right? So it contains the arrival and departure train. It contains the arrival and departure time of the corresponding train at this station, STN, right? And if the arrival or departure time is empty, we represent it as none. So let's see what's happening in this code block. Flag 1 and flag 2 are binary variables. They hold binary values of either false or true. Count is set to 0 and we go through each element in trains. Now remember that each x actually corresponds to some train that stops at the station, STN. So if first of x is none or last of x is none, flag 1 is being set to true. So when is it none? It is none if this particular station is either a starting or an ending station. So for example, if first of x is none, if this evaluates to true, what it means is that the arrival time for this station, the arrival time for this particular train is none. So if a train doesn't arrive at a station, it means it can only depart, right? So this is a starting station for this particular train X, right? So if the arrival time is none, that means there is only departure time. So the train is starting from the station. If last of x is none, that means there is no departure time, which means this particular train which x is actually pointing to is actually only arriving at the station. So this is the ending station for that particular train. So let me repeat. If the arrival time is none, that means this station STN is a starting station for the train. If the departure is none, that means this station STN is the ending station for a train. So if either arrival or departure time is none for a train X, that means flag 1 is true. So we can say that flag 1 is true if and only if STN is a starting or ending station for at least one train in the list trains. Right? So the next question is about count. So what does count represent? So let's go back. What does the variable count represent? So count, if you notice, is in the else part. It gets incremented in the else part. Now when will this else part get executed? When for a given train, let's say X, it is neither STN is neither a starting station nor an ending station, right? In that case, both of these will evaluate to false and then count will be incremented. Therefore, count is storing the number of trains for which STN is neither a starting nor an ending station, right? It is the number of trains for which STN is neither a starting nor an ending station. That is what count is storing here. Now finally, we are asked about the relationship between flag 1 and flag 2. So when is count equal to the length of trains? What does this mean? Count being equal to the length of trains. It means for every train in the list trains, STN is neither a starting nor an ending station, right? So flag 2 is false when STN is not a starting or an ending station for any train, right? So it will be true when STN is a starting or ending station for at least one train. So this is exactly what flag 1 is also actually storing. If you notice, flag 1 is true if and only if STN is a starting or ending station for at least one train. The same is true in the case of flag 2. Flag 2 is true only if count is not equal to length of trains, right? Because if count is doubly equal to the length of trains, then flag 2 becomes false. So for flag 2 to remain true, count should not be equal to length of trains. When will that happen? Count will not be equal to the length of trains if there is at least one train for which this else part is not executed, right? So when will this else part not be executed? If we can find at least one train for which STN is either a starting or an ending station, right? Therefore, flag 1 and flag 2 are actually calculating the same thing or represent the same thing. Therefore, flag 1 and flag 2 always store the same value. That ends the solution to this problem.